Well, hi everyone. Thanks for tuning in to this NGWA Waterworld Journal video interview called Catching Up. I'm Thad Plumley, the editor of Waterworld Journal, and today I'm speaking with Eric Macias, the Chief Operating Officer of Lorenz U.S. Corporation in Slayton, Texas. And we're going to discuss solar pump technology. With this August issue of Waterworld Journal focusing on green technology, we thought it would be a good time to catch up with Eric. Welcome, Eric.
Thanks for having me, Thad. Appreciate it.
All right, and yeah, thanks for your time. So I'm going to get started here. The first thing I think a lot of people think of when they think of solar pumps is they think they only work in climates that get sun. Exactly how much sun is needed for a solar pump system to be effective?
That depends on the flow rate that's required and the amount of head that the system is pumping against, as well as the size of the solar array. But if the system has been sized properly and is using a high efficiency DC brushless motor, then it should operate with as little as 15% sunlight, which is also defined as 150 watts per square meter of solar irradiation. This is also assuming that they're using higher efficiency monocrystalline panels that perform better in low light situations as well. But the solar array can actually be oversized to operate in very low light conditions. So let's say, for example, that we have four 200-watt solar panels, and those panels are producing 800 watts whenever the sun is at its peak, which is 1,000 watts per square meter. So we're producing 800 watts of power at that point. At 150 watts per square meter with 800 watts of power, that means that we would only be producing about 120 watts of usable electricity. And so if the system needs 600 watts in order to meet the head and flow requirements, then we're not going to be able to operate in that situation. But what most guys will do is they will just oversize it. They would say put 1,600 watts of power onto the system, and that means that, say, 37% sunlight, the system would operate as well. So it really comes back to, when do you want the system to turn on? How many gallons per day are you trying to achieve? And then that lets us size the solar array to the correct size to operate in the conditions that you need. One example I had for you is we have a very large swimming pool over in Hawaii, not too far where the volcano is going off, unfortunately, over in on the southeast side. And this particular pool has 3 pumps on it to filter the water, and they are actually able to achieve the peak flow rate of the pump, which is about 150 gallons per minute at 150 watts per square meter. The system was purposely oversized because the health department, who regulates swimming pools, wanted the pumps to be pumping at a minimum of 450 gallons per minute as soon as the sun came on, when the pool is set to open. So there's ways that you can make do in low light situations. It'll just increase the amount of solar panels that are needed and increase the cost a little bit, but it all depends on what the customer's needs are.
Okay, wow. So I know a lot of people are surprised that solar pump systems are not new technology. Can you give some of your personal background on how you've worked on systems from everything from dewatering to oil projects and landfill sump systems?
Sure. Yeah, in roughly 2006, Lorenz started manufacturing gas well dewatering pumps. I'm not sure why that's popping up. Apologize about that.
Okay. You want me to read the question again?
No, that's okay. I can start over for you there. You can edit it out, I guess, if that works for you.
Oh, yeah, no problem at all.
Okay. So in roughly 2006, Lorenz started manufacturing solar-powered pumps for gas well dewatering. Was the first application that we really stepped out of just groundwater pumping. And basically, as these gas wells start to age, the formation that produces the gas can also start to produce water. And that water builds up over the perforations, and it reduces the MCF production of gas out of that well. And so there's a lot of different methods to try and dewater these gas wells. But these wells are very remote. There's no power to them, and these wells only make, you know, 15 to 150, 180 MCF a day. So they're very low revenue wells, and the solution has to be very economical to be able to make it attractive and get a return on investment. So that's kind of where we first started in the oil and gas side of the business. Those wells, gas wells today, we've gone down as deep as 2,500 feet. As far as the salinity of the water, the salt content, we've worked with up to about 8.5% salt. For example, seawater would be roughly 3.5% salt. So we've been in some pretty nasty situations. Those are a lot of fun though, because it's extremely challenging for our product, but also it's challenging to find solutions to make the system last. And we've seen systems out there that are going on 6 years with never coming out of the hole. And typically the operators will see a 1 to 3 year return on investment, depending on how strong the well comes back on with its production. In regards to oil pumping, we've also got pumps down to about 2,100 feet currently. I would say about 50% of the stuff that we do is solar powered and 50% is AC powered. So we're actually utilizing our submersible progressive cavity pumps for pumping crude oil. And of course, there's always water and there's always gas generally present with that crude oil as well. So it's just not straight crude. You've got a mixture of gas, water, and oil in most of these applications. And so in those environments are definitely challenging because most of these wells have been fracked. And when they frack a well, they use frack sand, which of course is very abrasive to a pump. So you're always having to use your sensors that the pump is equipped with and the controller can use to monitor the performance of the amperage, the flow rate, the levels, and how the decline curve of that well is acting, because that allows you to really have a gauge and a sense of what that well's doing, how the pump's performing, and it really lets you be able to tell when something bad is going on, such as all the frac sand coming back into the well, covering up the perforations. You can really start to pinpoint those things and be able to protect the pump system. So most of our oil companies that we work with, it's very similar to the water pumping windmill. Ranchers have realized that it's much more efficient to use a solar powered pump to provide water for livestock. But a pump jack operates very similar to a windmill. And there's a lot of maintenance required to them. There's no automation. They don't have any historical data that they're capturing of well performance. And so the oil companies have started to realize that these progressive cavity pumps that have all the data monitoring, level sensors, pressure sensors, flow sensors, are able to give them so much more information on how to operate their field, reduce their operating costs, reduce maintenance costs. We've got a lot of oil companies that have told us they will not drill a new well that doesn't have the new equipment in it, because it's so much more effective and cost effective, reduces labor and downtime for them, that's been a very good part of our business as well. So I can tell you probably the grossest and nastiest situation you get into in pumping, my experience thus far, has been leachate. These horizontal wells are underneath landfills, and so no one really ever knows what's been put into that landfill. Everyone says, well, it's just solid waste, but you always hear the stories of worse things making their way into that landfill. But you really have high viscosity fluids, you have high temperatures that are present, and then you also have abrasives that can be present as well. And we're using a progressive cavity pump there again, because those pumps are suited for pumping multi-phase fluids such as oil water mixture or a oil gas mixture, things like that are always present in these situations. So the pump is set up to able to handle it, and we've seen where they're using centrifugal pumps, which is absolutely the wrong pump to use for the application. We've seen those pumps last 6 weeks, and we have pumps that are out there making it 3 years. So it really, really reduces the amount of labor and equipment cost. Yes, they'll have some higher upfront costs to replace it with the right equipment versus a standard water well pump. But it really makes a big difference on the longevity and the operational bottom line for the landfill operators. So, but those are kind of some of the ones that we've been into and that we really focus on, and those all really have helped us improve our water well products as well. So it's not that we are spending resources on the energy side of our business without getting any return on the water side. It's really helped us improve the abrasive handling capabilities of the pumps, and also it's brought a lot of new control programming into our controllers to be able to automate the systems and do such thing as level sensors, pressure sensor control, things like that. So there's a lot of benefit that transfers over to the water side of our business from those three other industries.
Yeah. I know obviously you have an article on hybrid pump systems in the Water Well Journal August issues that our readers are going to be getting here very soon. I know in it you wrote that solar pumps could impact the bottom line for contractors. Can you give a few tips for someone maybe wanting to learn how to install a solar pump and what they need to do to get started in this?
Well, before we scare anybody off, I want to say that I've worked on AC pumps and solar pumps since 2000, whenever I got into the pumping industry. And in my opinion,
Okay.
solar pumps are actually easier than AC pumps because you have DC power that you're dealing with.
Oh,
In
wow.
many cases, you don't have to worry about, whether you've got single phasing, low voltage, over voltage, those things coming from the power company. You really have kind of a fixed power input, and for me, that always made it easier to understand what was going on. So, the first thing is don't be scared. Don't be afraid to step outside the box. But number one, I would say my first tip would be to align yourself with a supplier that can support you um, and that can provide training. With proper training, you're going to be able to avoid costly mistakes and be more profitable on your projects. And there's local classes that are available. Some of those are more of a sales presentation, but we really try to focus on hands-on, real-world troubleshooting. The channel managers that are on the Lorentz team in the U.S. have all been water well contractors. They've set pumps, they've done solar pumps, they've drilled wells. So we really have a great experience level of practical information, field experience, along with the technical engineering side of our business. So it's a really good mixture that really provides a good hands-on and a little bit of classroom training to help contractors be more effective at troubleshooting pumps, but also sizing pumps from the beginning and putting them in the right application to make sure you're successful. So the training is really key, and the suppliers out there need to hear it from the contractors that we need training, we're interested in training, because that helps them allocate resources and time, because there's several new products in the water well industry, such as drives or things like that sometimes everyone may get on a kick of doing drive training for a little bit or solar training for a little bit, and you just need to voice what your needs are, because your suppliers are definitely more than happy to provide the training if you'll just ask and tell us what kind of training that you're looking for. Um, and those basic classes can be anywhere from 4 to 6 hours. But we also have, for example, a 3-day course that is very hands-on, very intensive. I would say it's not for beginners. It'd be for somebody that has been to at least one local style class. But that initial first step of investing your time in training, getting the proper training, is really going to help you tackle those projects and be more effective and not have forget materials or do an incorrect installation where you have to go back later and it costs you money there. So, but I would say probably one of the most important things is to get the right meters. Uh, Most often, um, everybody has AC meters as standard on their trucks, but they don't have DC meters. And some meters are dual AC and DC, but it seems like that's usually something that happens is not having the right meters out of the box. And what I use is a Fluke 376. I would definitely recommend it for an AC DC meter. It's a true RMS meter. It does AC volts and amps. up to 1,000 volts. And it's also something that you're going to need to work on variable frequency drives on the AC side of the business. So it's going to be dual purpose for you. It's not going to be, something that's just specialized for solar. That meter also has an ohm meter in it, built into it, digital ohm meter, and that's also very handy for those troubleshooting and also first installation points. One of the most commonly underused meters is a megger. A megger is something that you absolutely need if you're going to work on solar pumps or you're going to work on variable frequency drives. I can't tell you how many guys we've had in our training classes that have bought meggers and gone home and said, I found the problem that I was having on this drive where I was having to replace it every year, every 18 months, ended up being found with a megger. Same way with a solar pump. So that's one of the best investments you can make, and a megger is about $250 to $300, depending on freight and all that, where you get it from. But it's definitely going to pay you back. I promise you that. Sadly, we've had several contractors that have put multiple controllers on pump systems, and the controller dies, in 6 months, and they put another one 6 months later, and it dies. And, then they come back and say, well, the controllers, we're having issues with them. We think it's a quality issue. But most of the time it ends up being, a poor connection in wire nuts, a poor splice. Bad cable is very common, where they've had nicks in the cable, or they've had an electrical surge down the cable that's caused an issue. But that megger is going to find it. I was going to tell you about a story last week. We actually had a contractor that I was kind of giving him grief when we pulled up to the job site. There were two old dead controllers hanging around the solar panels, and it kind of reminded me of like the talking heads cut off of around the witch doctor or whatever. Here's two dead controllers. And so I looked over at him, I said, yeah, that's a bad omen right there. I said, but I'll guarantee it, you've got a problem in your cable. And he said, how do you know that? And I said, well, you got two controllers and you're saying the third one's bad. We're going to find it in the cable. So sure enough, we pulled the megger out. They had flat yellow wire, which is definitely not recommended on a drive or a solar pump, single jacketed wire. And sure enough, there was a short that had led to the cause of the other two controllers failing. The contractor pulled the pump. He changed the wire to a double jacketed flat black double jacketed cable. System kicked off and ran perfectly. And the next day he was actually in town, and he went over to the supplier and bought a megger that next day. So, I promise you it'll pay you back. If you don't have one, you're going to cost yourself money, or you're going to cost your customer money that doesn't need to be spent. The last little meter that I would recommend if you're working on solar pumps or drives would be an AC or DC Milliamp Meter. A lot of the drives and solar pumps nowadays are using level sensors or level transducers, pressure transducers, and those use a 4 to 20 milliamp feedback. It could be AC or DC. And so a little DC or AC milliamp meter helps you determine what that feedback signal is. Most of the drives are going to tell you if there's a fault, if the sensor's not sending a feedback signal, but it's always nice to be able to see what that signal is rather than just it's bad or not getting the signal. You can kind of, double check both sides of your equipment to make sure it is the sensor or it is the I/O board of a controller or something like that. But, those meters in your tool bag, they're going to help you. The last piece I would say as far as a tip wise, groundwater contractors are looked to as the experts. When their customers approach them about needing water, they may not necessarily know that they need a solar pump right away, but the contractor is going to say, hey, we can do a solar pump rather than run electricity. It's going to be more cost effective for you. But I would say that the contractors should make sure that they're endorsing a product that is sold through professional channels. If you endorse the product, it's too easy for an end user to go over and look on the internet and then just take all of that valuable information and sizing and all the work that you did to show him how to set up the system and just purchase it around you. And so, I would just make sure that you're using a system that is professional grade and helps keep the channel to where you're getting a return on your investment for doing the time of designing a system providing guidance to the end user of what to do for a water system. So,
yeah, that is for sure. So what are you hoping Water World Journal readers take away from the article? Kind of what's the end message that you want them to take away?
I'm hoping that kind of the end message will be to keep up with technology. Don't let it pass you by. We still have customers that have flip phones, and that's okay. We have customers that still don't use computers. They send things via mail and, no email, and that's okay. But, today's, today's end users, they're wanting products that are automated, that are connected to be able to hook up with smartphones. They want to see performance data. They want to see historical well data. They want that automation, and all those things add value to the system. And that's something that allows the contractor to have value and also, not worry about somebody selling over the internet. He can do things that nobody else can and actually make a good profit on that as well. And, it just helps differentiate yourself from your competition. As a young guy in the industry, whenever I first started, I just gravitated towards equipment that other people didn't know anything about. I worked with guys that had been in the industry for, 25, 40 years, and I wasn't ever going to teach them anything about a submersible pump, a sub turbine or anything like that. I was soaking up everything they would teach me, but they didn't know about drives or they didn't know about solar pumps. And that's where I saw that I could add some value and help them versus trying to, reinvent the wheel about a pump that they've worked with for, before I was born. So, that's one thing that, I think that the younger folks in the industry should try and strive for is learning this new technology, being masters of it, because they'll really add a lot of value to their position that they have with the company, wherever it is. But utilizing that technology is going to make your operation more efficient. It starts out with the most time-consuming processes. If you ask most water well contractors that we've spoke with, where they have to go do callbacks and troubleshooting that they can't find the root cause, that's really what is a thorn in their side and really costs them a lot of money and, more importantly, time. And so the apps that we have, that allow you to hook up to the controllers and see the historical data, those are really what's going to help your business get a little more efficient on troubleshooting and things like that. It also lets you get the information to an expert. Your guy running the pump rig might not be an expert on solar pumps, but when he brings the data back of the performance and he gets that in front of the right person, most generally the right person can interpret that data and tell you what's going on. So there's, I would say just keep up with technology. Smartphones, yes, they can be aggravating. Believe me, I've threatened to throw mine out the window once a week at least, but they can also be a very valuable tool too. So